In this video, we're going to talk about how to use CPCTC in two-column proofs. So first, let's review the four postulates that you need to prove that two triangles are congruent. The first one is the side-side-side postulate. So in this case, all three sides must be congruent. If they're congruent, then you could prove that the two triangles are congruent. After that, you have the side angle side postulate, where you need a side to be congruent, the included angle, and another side. After that, we have the angle side angle postulate, where you need an angle to be congruent, and then a side, and then another angle. The side has to be between the two angles. And finally, there's the angle side postulate. In this case, you need an angle to be congruent, another angle, and then the side. Now consider these two triangles. Let's say the first one is triangle ABC, and the second one DEF. Once you prove that two triangles are congruent, let's say ABC is congruent to DEF, then you could use CPCTC to prove any portion of these two triangles are congruent. So CPCTC is usually the last part of the reasons column in a two-column proof. It basically states that corresponding parts of congruent triangles are congruent. So if these two triangles are congruent, I could say that AB is congruent to DE. I could say that angle C is congruent to angle F. I can make any statements about any corresponding parts and show that they're congruent, or state that they're congruent based on CPCTC if I prove that the two triangles are congruent. So the best way to learn this is through a series of practice problems. So consider these two triangles. Let's call the first one triangle ABC and the second one triangle DEF. Now you're given that AB is congruent to DE, and also BC is congruent to EF, and that CA is congruent to FD. So your task is to prove that CA or rather, let's change it. Go ahead and prove that angle C is congruent to angle F. So let's make our two-column proof. Statements, and reasons. So the first statement that we could say is that AB is congruent to DE. And the reason for that, it's given. So let's write that on a picture. So this is AB is congruent to DE. Now in step 2, we could say that BC is congruent to EF. And that's given as well. So here's BC, and it's congruent to EF. Now in step 3, we could say that CA is congruent to FD, and that's also given. So now what postulate can we use to prove that these two triangles are congruent? So in step 4, we could say that triangle ABC is congruent to triangle DEF. Now make sure you write this in a certain order. Notice that A corresponds to BC, and D corresponds to EF, and BC is equal to EF based on the two tick marks that you see there. So A has to match up with D. B is opposite to the side with 3 tick marks. The same is true with E. So when saying two triangles are congruent, B has to match up with E. F is across the side with 1 tick mark, and C is across the side with 1 tick mark. So C and F correspond to each other. So for those of you who might be wondering how you should write these letters and in which order, make sure that the first two angles match up. Angle A has to be congruent to D. And typically, if the sides are congruent, then the angles opposite to those sides has to be congruent based on the side angle theorem. Now we can say that these two triangles are congruent based on the side, side, side postulate. Now we've used statements 1, 2, and 3 to show that those three sides are congruent. So let's put 1, 2, and 3. Now once you prove that the two triangles are congruent, the last step, in my experience, is always going to be CPCTC. Now you can prove that any corresponding parts of these two triangles are congruent. In this case, we can say the final sentence or make the final statement. So we can say that angle C is congruent to angle F based on CPCTC. Corresponding parts of congruent triangles are congruent. And that's it for this problem. Now let's work on another example. So let's say this is A, B, C, and D. And you're given that BD is perpendicular to AC. And also B is the midpoint of AC. So your task is to prove that AD is congruent to CD. So feel free to pause the video if you want to try this problem. So prove it using a 2-column proof. So let's start with number 1. So we're given that BD is perpendicular to AC. And let's write given. So what conclusions can we draw from that statement? If BD is perpendicular to AC, what do we know? Perpendicular lines form right angles. So that means that ABD is a right angle and DBC is a right angle. So we can make another statement. We can say that angle ABD is congruent to angle CBD. And the reason for that, perpendicular lines form right angles. Now what else can we say? Well, we have another given statement, and that is that B is the midpoint of segment AC. And so that's given. Now, what conclusions can we draw from that given statement? If B is the midpoint of AC, what do we know? Well, if B is the midpoint, that means AB is congruent to BC. They have to be of the same length. And the reason for that is definition of a midpoint. Now, what else can we say? What else do we need to prove that the two triangles are congruent? Now, notice that triangles ABD and CBD share a common side, and that side is BD. So we could say that BD is congruent to itself according to the reflexive property. Now we can prove that the two triangles are congruent. So we can say that triangle ABD is congruent to triangle CBD. And the reason for that, we have a side, an angle, and a side. So it's the side angle side postulate. And to prove it, we've used statements 2, 4, and 5. Now, once you prove that the two triangles are congruent, the last step is going to have this statement, the statement that you're trying to prove, that AD is congruent to CD. And all you got to say is CPCTC. That's the reason. Corresponding parts of congruent triangles are congruent. And then this problem is done. That's it. Let's work on another example. Let's say this is the center. And let's call this point A, B, C, and D. And so you're given that E is the center of the circle, and that's all you're given. Just E is the center of the circle. And you want to prove that segment AB is congruent to segment CD. So all you know is that E is the center of the circle. Prove that this segment is congruent to that segment. Alright, so let's begin. Let's start with our two-column proof. So number one, point E is the center of the circle, and so that's given to us. Now, what conclusions can we come up with, knowing that E is the center of the circle? Now, you need to know that the distance between the center and any point on the circle is the radius of the circle. And the radius of the circle is the same anywhere on the circle. So that means that AE is the radius of the circle, EB is the radius as well, ED and CB are all radii of the circle, which means they're all congruent to each other. But because we want to prove that the two triangles are congruent, let's take this one step at a time. So for statement 2, we're going to say that AE is congruent to DE. So here's AE that's congruent to DE. Now we can also say that BE is congruent to CE because they represent the radius of the circle as well. But I'm going to use a different tick mark. So we can see that we have two sides of the two triangles that are already congruent. Our goal is to prove that this triangle is congruent to that triangle. If we can do so, then using CPCTC, we could say that this statement is a true statement. So what should we put in the second column for this statement? What's the reason? Well, the reason is simple. All radii of a circle are congruent. So that's the reason. Now let's move on to step 3. What else can we say? Whenever you have two lines or two segments that intersect each other, well, technically two lines, they will always produce vertical angles. and vertical angles are congruent. So what we could say is that angle AEB is congruent to which angle? So this is AEB. And we know that it's congruent to this angle. But how should we call it? Should we say it's angle DEC or CED? Think about it. Well, let's find out. So A matches to what letter? Does A match C, D, or E? So notice that A is opposite to the side with 2 marks. So therefore, D is opposite to that same side. But technically, it turns out that both answers could work, because since every side represents the radius, all 4 angles must be equal to each other. But if they were different, I would say that A and D would match up because they point to the same side with the same number of tick marks. But for this particular problem, everything's the same. These 2 sides are equal, so therefore these 2 angles are congruent. So you could say DEC or CED for this particular example. But for other examples, I would keep it safe and say that A matches with D if these 2 are different. So this is going to be equal to angle DEC. Now, why can we say that? So as we mentioned before, the reason why they're congruent is because they're vertical angles. So the reason is vertical angles are congruent. Now, number 4. So now we can say that the 2 triangles are congruent. So triangle AEB. Oh, this is supposed to be a B, by the way. I don't know why I made that a D. So let's fix that. So that's supposed to be angle AEB is congruent to DEC. So now triangle AEB is congruent to triangle DEC. I'm making too many mistakes here. Now, what's the reason? What postulate can we use that to prove these 2 triangles? So we have a side, an angle, and a side. So it's SAS. Now, what statements did we use to prove that those 2 triangles are congruent? So for this side, we use statement 2, which state that AE is congruent to DE. So we got to go in order. Next, we have the angle. So we use statement 3 to prove that the vertical angles are congruent. And then this side is based on statement 2, where BE is congruent to CE. So it's going to be 2, 3, and then 2. So now that step 4 is finished, and that the 2 triangles have proven to be true, we can now move on to our last statement, which is the statement that we're trying to prove. And that is that AB is congruent to CD. And the reason is CPCTC. Corresponding parts of congruent triangles are congruent. Now let's work on another example. So let's call this A, B, C, D, and E. Now we're given that AB is parallel to DE. And we're also given that segment BD bisects segment AE. So with this information, prove that segment AB is congruent to segment DE. Now at this point, if you want to try the problems, just pause the video and work on it and see if you can get the right answer. The best way to learn is by practicing these problems, and then as you begin to do them, the more that you do these problems, the more you understand like what to do next, what reasons to put, and just how to go about to solve like these types of things. So let's begin. So in the first column, let's put statements, and in the second one, reasons. So let's write the given. AB is parallel to DE. So that's given. And let's mark it on a graph. So this is the symbol to indicate that two lines or two segments are parallel. Now, what can we figure out with this information? So knowing that AB is parallel to DE, what can we deduce? Whenever you have parallel lines, look for alternate interior angles. So we could say that angle A is congruent to angle E. You could also say that angle B is congruent to angle D, but we'll take it one step at a time. So let's say that angle A is congruent to angle E. Now, what reason can we put? So here's what it needs to say. Alternate interior angles are congruent. So that's the reason. Now, next, let's write that BD bisects segment AE. So this is BD, and it splits AE into two equal parts, which means that AC is equal to CE. And for statement 3, that's simply a given. But for statement 4, we could say that AC is congruent to CE. And a reason, definition of a segment bisector. Now, number 5. We could say that these two angles are congruent because they represent vertical angles. So we're going to say that angle ACB is congruent to angle ECD. So notice that D corresponds to B. They're opposite to two congruent sides. So I have to make sure that B matches with D. And the reason? Vertical angles are congruent. Now let's move on to statement 6. So we can now prove that the two triangles are congruent by the angle side angle postulate. So triangle ACB is congruent to triangle ECD. And so the reason for that is the side angle side postulate. And first we had angle 2, which corresponds to, statement 2, which corresponds to that angle. Angle A equals angle E. Next, we proved that the sides were congruent. So AC is equal to CE, so that's statement 4. And then the vertical angles are congruent, which was based on statement 5. So now we can make the final statement that segment AB is congruent to segment DE using CPCTC. So let's call this A, B, C, and D. So in this problem, we're given that angle B is congruent to angle D, and also that ray AC bisects angle BAC. Actually, not BAC, but rather BAD. Go ahead and prove that segment BC is congruent to DC. So feel free to try this problem. Okay, let's start with number 1. So we're given that angle B is congruent to angle D. So that's a given. And now let's mark it on the graph. So B is equal to D. Now what else can we do? So number 2, we know that ray AC bisects angle BAD. So this is ray AC. It emanates away from point A. And so it bisects angle BAD into two congruent angles, which means angle BAC is congruent to angle DAC. So number 2, this is a given. But in number 3, we could say that, let's put a line to separate these two, the given from the actual problem. So in step 3, we could say that angle BAC is congruent to angle DAC. And the reason for that is definition of an angle bisector. Now let's move on to our next step. In step 4, we could say that AC is congruent to itself due to the common side that we see here. And that's based on the reflexive property. Now step 5, we could show that the two triangles are congruent using the angle side theorem. So we could say that triangle BAC is congruent to triangle DAC. And this is based on the angle side postulate. So the first thing we did, we proved that B is congruent to D. So that was the first angle we proved, and that was based on statement 1. And then we showed that angle BAC and DAC are congruent. So that's based on statement 3. And finally, the common side, which was the S symbol, and that's for statement 4. So it's based on statements 1, 3, and 4. And now let's make the final statement that segment BC is congruent to DC. So here is BC and this is DC, so they're the same. And the reason for that, as always, CPCTC. Corresponding parts of congruent triangles are congruent. So let's call this A, B, C, D, and E. So we're given that angle 1 is congruent to angle 2. And you might be wondering, where is angle 1? So this is going to be angle 1, and here is angle 2. And also C is the midpoint of AE. So go ahead and prove that segment AB is congruent to segment ED. So number one, let's start with, let's see, the angle. So angle 1 is congruent to angle 2. So that's given. Now our goal is to prove that triangle ABC is congruent to EDC. If we can do that, using CPCTC, we can prove that this statement is correct. But angle 1 and 2 are outside of those two triangles. And we need angles that are inside the two triangles. So let's call this angle 3 and angle 4. Now, if angle 1 is 100 degrees, that means angle 2 is 100. Now, 1 and 3 forms a linear pair. They're supplementary. That means 3 has to be 80 and 4 has to be 80. So therefore, angle 3 and angle 4 are congruent to each other. So let's write that in the next statement. Angle 3 is congruent to angle 4. And the reason for that is supplements of congruent angles are congruent to each other. And so let's mark that. So 3 is congruent to 4. Now let's move on to the next part. C is the midpoint of AE. And that's a given. So what can we conclude anytime we have a midpoint? A midpoint separates a segment into two equal segments. So we could say that segment AC is congruent to segment CE. And the reason is definition of a midpoint. Now the last thing we could do is prove that these angles are congruent. So in step 5, we could say that angle ACB is congruent to angle ECD. And the reason vertical angles are congruent. Now let's move on to step 6. So now we can prove that the triangles are congruent. We have an angle, a side, and an angle. So let's say that triangle ACB is congruent to triangle ECD. And that's using the side angle, actually that's the wrong one. It's the ASA angle, side angle postulate. And the first angle that we proved was angle 3 is congruent to angle 4. So that's based on statement 2. And then for the S, we proved that AC is congruent to CE, so that's statement 4. And then statement 5, the vertical angles. So it's based on 2, 4, and 5, angle, side, angle. And now finally, we could say that segment AB is congruent to segment ED based on CPCTC. Now let's try another problem. So this one might be a little bit harder than the other ones that we've been dealing with so far. So let's call this A, B, C, and then this is going to be D and E. In this problem, we're given that angle 1 is congruent to angle 2. So this is angle 1, and here is angle 2. And we're also given that DC is congruent to EA. Our task is to prove that segment AD is congruent to segment EC. So go ahead and work on this problem. So number one, let's start with the angles. Angle 1 is congruent to angle 2, and that's given. Now notice that angle 1 and 2 are part of a single triangle as opposed to two separate triangles. So what can we conclude from this information? And also, what is our goal? In order to prove that AD is congruent to EC, we need to prove that triangle ADB and this triangle CEB, they have to be congruent. Or if you can prove that the triangle ADC is congruent to AEC, you can also prove that AD is equal to EC, depending on which one is easier. I'm going to go with the first two triangles that I drew. So let me redraw. So this is A, B, D, and here we have C, B, E. So if we can prove that those two triangles are congruent, then we can easily prove that AD is congruent to EC. Now let's focus on triangle ABC. That triangle is an isosceles triangle because two angles are the same, which means that the sides across those two angles, AB and BC, must be equivalent. So AB is congruent to BC. And we could say the reason for that is the base angle theorem. Within a single triangle, if the angles are congruent inside a single triangle, then the opposite sides are congruent. So far, we've been dealing with congruent angles of two separate triangles, but whenever you have within a single triangle, if two angles are congruent, then the opposite sides will be congruent based on the base angle theorem. So right now we know that AB is congruent to BC. Now what else do we know? So notice that angle DBA and EBC, those are congruent angles. They're vertical angles, and we know that vertical angles are congruent. So let's mark that. So these angles are congruent. And now we just need one more detail, one more piece of information. So let's use the fact that DC is congruent to EA. And that's given. So here is DC and here is EA. So they're congruent, and we know that BA is congruent to BC. Therefore, by intuition, you can see that DB is congruent to BE. We just have to show it. Once we can prove that DB is equal to BE, we can prove that these two triangles are the same. So we need to perform segment addition. So whenever you need to perform some sort of mathematical operation with segments, you need to change this into a certain value. So we're going to say that DC is equal to EA, And this is definition of congruent segments. Now, notice that DC is basically DB plus BC. If you add those two, you're going to get DC. And in addition to that, EA is basically AB plus BE. That will add up to segment EA. So let's replace DC with DB plus BC. And then let's replace EA with AB plus BE. And so whenever you're breaking down two segments, or a large segment into two segments, or if you want to add two small segments into a larger segment, the reason or the property is segment addition. Now, what do you think we should do at this point? What's our next step? Now, looking at statement 2, notice that AB and BC are congruent. So we could therefore replace BC with AB. So in step 7, we're going to have DB plus AB is congruent to AB plus BE. So we've replaced or substituted BC with AB. So this is going to be the substitution property. So I'm just going to write substitution, but on the test I would put the word property as well. I'm running out of space. Now in step 8, because we have AB on both sides, we can subtract both sides by AB. Thus it's going to cancel these two. And so we're going to be left with DB is equal to AB according to the subtraction property. Now in step 9, we can say that segment DB is congruent to segment AB. And why can we say that? Definition of congruent segments. So now that we have that again, we can say that we can put the marks in the graph. DB is congruent. I don't know why I put AB. Let me fix that. AB should be canceled. That should not be an AB. That should be gone. So it should be BE. For long problems, it's easy to make a mistake. So DB is congruent to segment BE. And let's rewrite this definition of congruent segments. And let's put the mark here. DB is the same as BE. So now we could show that these triangles are congruent based on the side angle side postulate. So for statement 10, we're going to say that triangle DBA is congruent to triangle EBC. And this is based on the side angle side postulate. So we've used number 2, number 3 for the vertical angles, and also number 9. So it's 2, 3, 9. Now finally, we could say that in statement 11, what we're trying to prove, AD is congruent to EC. And so that's based on CPCTC. Now let's consider our final example. So let's say this is point A, B, C, D, and E. And in this problem, we're given that BD is congruent to BE. And also that AD is congruent to CE. Prove that AE is congruent to DC. So go ahead and try this problem. So let's start with number 1. Now we know that BD and BE are congruent. So let's write that. And that's given. Now, in order to prove that AE is congruent to DC, what triangles do we need to prove must be congruent? So if we can prove that triangle BE or BAE is congruent to BCD, then we could show that AE is congruent to DC. So just keep that in mind. Now let's write the second given. AD is congruent to CE. And I'm going to write what we need to prove on top so I can make some space on his board. Now let's draw the triangles that we need to prove that are congruent. So this is triangle ABE, and we need to prove that it's the same with BDC. Now we know that BE is congruent to BD, so that's the first part, that's finished. And in the second sentence, we know that AD is congruent to CE. So if we can add these two segments and combine those two segments, then we can show that this side, AB, is congruent to BC. So let's do that. So let's change this. This is going to be AD is equal to CE. And that's definition of congruent segments. So now what I'm going to do is I'm going to add BD to both sides of this equation. So in step 4, AD plus BD is equal to CE plus BD. And that's basically the addition property. The addition property of equality. Anytime you add to both sides of the equation by a constant value, that's the addition property. Now in step 5, notice that BD and BE are the same. So on the right side, I'm going to replace BD with BE. So I'm substituting BD with BE. So that's the substitution property. Now in step 6, we can add AD and BD. So this is AD and this is BD combined. That is equal to segment AB. So AD plus BD is AB, and CE plus BE is basically BC. So AB is equal to BC based on segment addition. Now in step 7, we can say that segment AB is congruent to segment BC, and that's definition of congruent segments. So now we can mark that on the triangle. So this is AB and this is BC. They're congruent. Now notice that these two triangles share a common angle, that is angle B. So in step 8, we could say that angle ABE BE is congruent to angle CBD. And we can use the reflexive property for that because it's a common angle. Now in step 9, we can now say that the two triangles are congruent. So triangle ABE is congruent to triangle CBD. And this is based on the side angle side postulate. So let's start with this one. Actually, no, wait, let's start with this one. So that's based on statement 1, BD is equal to BE. And then we have the angle, which is based on statement 8. And then the third side, or rather the other side, that's based on statement 7. So 187. And for step 10, we could say that segment AE is congruent to segment DC because corresponding parts of congruent triangles are congruent, CPCTC. And that's it.